Welcome, everybody, to today's webinar on the brand new next generation Terasaki TemBreak Pro molded case circuit breakers, which are now being launched throughout Australia and soon to be in New Zealand. My name is Nicholas Burley, and I'm the Power Solutions Manager at NHP. And joining me today, we have George Matter, who is our Product Manager for the Terasaki molded case circuit breaker range. How are you going, George?
I'm good. I'm good. So today we're going to talk about the new generation of the breaker that been we've been working on it for years. I'm totally excited to talk about it today for everyone.
Excellent. Well, let's have a look at, first of all, how we started with the development of this new range, because I know you traveled all throughout Australia and New Zealand talking to customers. Tell us a little bit about that.
So in 2016, when I joined NHP, I've been introduced about the new development and that Terzaki have been working on. And instead of just going there and accepting what Terzaki have got there, we went out to the market and we heard, and especially in Switchboard builders live and for consultants as well, where we knew about what are the feature and benefits they wanted, where the developments they looking for, and what are the improvements they want to have in the new range. And that helped us to summarize all of it with Terzaki, work on it since 2017 till this year, where we managed to get majority of what's been requested in the market in the new development and cover majority of what been requested.
Excellent. So we certainly used all that feedback to help drive the development with Terasaki. So let's have a look now at a couple of the changes that you'll see coming through in the new range. First one, George, is a new contact design that's been integrated into the system.
That's exactly right, Nick. So the new breakers have got new designs. Whether it's a new contact due to the brand new contact mechanism or upgraded to have a better rating due to using a higher temperature ratings, and that will help to reduce cost and optimize designs of the boards, which we're going to cover later on.
Excellent. So we've got upgrades and new designs with our contact system. Great performance. Now, performance is one of those things when it comes to circuit breakers. The better the performance, be it temperature, be it short circuit, the overall the performance of the switchboard dramatically improves. So I think we're going to talk a bit more about that performance factor a little bit later on in some of the slides, but we've got some great figures that we've seen out of it. Finer adjustment. Now, I know this is a big step forward with the trip units.
Yep. So one of the feedbacks we got it from the market is the selectivity and the adjustment for the selectivity. And one of the things that we worked on through Zaki is how we can get even the existing trip units upgraded to have a better fine adjustment. And with the new trip units, how we make sure that it's completely covering the fine adjustments being requested by the market. And we're going to cover it later on.
Localized solution for easy compliance. So NHP is the distribution partner with Terasaki. So we've worked very closely with our customers to make sure all the manuals and the ratings and the data tables are all localized for our customers and complying with AS NZS standards. Measurement and communications. We've made some big improvements in this space as well, which we're going to look at soon. George, give us a quick update. What can we expect to see from the comms and the measurement side?
So with the new breakers and the new development of the trip units, we got a better screens, we got massive number of measurements that and the measuring values goes up to 200 plus values, which we're going to cover it later on. That helps to monitor the sites, give all of that data through the communication, which help to optimize the operation at sites and help the owners and the operators to reduce their running costs.
Excellent, excellent. And then finally, looking at the range, it's quite a large range, all the way from 160 amp frame up to 3200 amp frame. So TemBreak Pro is certainly got a lot of different frame sizes and trip unit types to meet whatever requirements customers have.
That's exactly right.
So just talking about the range, let's cover off on a few of the key facts here. So as I said, all the way up to 3200 amp is what we're offering, and we have four models to match the application. So we try to keep it simple and easy for selection. So you'll find there's a thing called the A model, and A models are typically used in basic applications. They're the smaller frame sizes, 160 amp, 250 amp. So that's typically where you'll use those. The P model, and we're going to talk a lot about the P model, particularly in this presentation, because that's where there's been some big improvements in performance and trip units and things like that, specifically with this P model range. So that's from 160 amp up to 630 amp frame size. The B model, you can use that between 160 amp up to 1600 amp. And typically you'll be using a B where you're looking for higher KA ratings or some of those larger amp frames, as I said, 1250, 1600. And then the really large frame size breakers, so your 2000 and your 3200 amp frame size, that's the XS model. So that's how it's broken up. Four models based around the current requirements, KA requirements, and the application types. And then when you're looking at KA types, we've actually had some big improvements there as well, George, because we've got 10 performance levels
Yep,
now.
that's exactly right, Nick. So one of the feedbacks we got it from the market is that we have a big step between the frame sizes and based on the trip units, based on the ratings, you have that big step. We worked with Trozaki to cover these gaps, and now we have a granular short circuit levels between 25 all the way up to 200, and we can go from 25, 36, 50, 70, 100, 110, 125, and 200Ks. All of them, you can have nearly all type of trip units, all ratings within that bucket. So it covers majority of what we need in the market and will make it easier and optimize cost for the customer as well.
Excellent. Another change that you brought on board was reconfiguring the part number structure to make it clear and simple for customers to be able to define what they want. And just from the part number, you know everything you need to know about the
That's
breaker.
that's right, Nick. So the feedback we got it from Switchboard builders is that they like the simplicity of the part numbers. They got one part number all the way from the designing, from the purchasing, from receiving in the stock, but they struggle to understand that structure of the part number. To simplify it for them, what we did is we restructured the part number with Terozaki and we got a more simplified and consistent part number, which tells you exactly the rating of the breaker, the features of the TRP unit, the short circuit levels, and all of that they can have it in the part number as itself. And that part number is printed in all our documents. It's also printed on the breaker box itself. So the customer can actually see it on the receiving in the warehouse. They can actually use it in the designing. They can actually use it in the specification. So all the cycle of the design network, quoting, ordering, and receiving, all of it using one clear part number.
Excellent. And I know that another thing that was based on customer feedback was around using color to be able to identify some of the characteristics of the breaker. So I know this was fed back by one of the switchboard customers that we spoke to about being able to put some color on the labels, and you're able to work that through with Terasaki. Tell us a bit about that.
So the good thing about having a different color label to indicate what is the type of the trip unit is that most of the breakers will be sitting behind a section in the board. So that covers the trip unit, covers the head of the breaker, and it only leaves the toggle area. With the toggle area and the part number written on the label and the color of the label, you can easily identify what is the trip unit behind that section without opening it, which means for retrofitting, for replacement, for future extensions, you don't have to open the whole board. It's just a picture of that label will tell you all the story about the breaker itself.
So from what you can see here, a breaker with the white label is the thermomagnetic. The grey label is a basic electronic, and the blue label is what we call the smart electronic, which is the metering style MCCB. Okay, so three colors tells you a lot about the trip units.
That's exactly right. And all of them are consistent all over the range. So whenever you see white label, definitely that will be a thermal mag breaker. If you're looking for the gray label, that will be basic electronic. And if you're looking for the blue label, that will be a smart electronic.
Now, just continuing on talking about trip units, as we said, there's the three types: the thermal mag, the basic electronic, and the smart electronic type. Now, I know you've got your own particular favorite trip unit out of everything that's available, and I believe it is this one here, the basic electronic BE that you'll find in that P model type that we spoke about.
Yep.
Why don't you give us a quick run through as to what customers can expect to see from this style of trip unit?
So that type of trip unit can go down to adjustment of 1% fine tune adjustment. And that is for the long time. You can also adjust the long, short, instantaneous, all of them in one type of trip unit. You're not having different trip units to adjust it. It's one basic trip unit in there. And that trip unit, you can switch off the L, which means you can have an instantaneous only trip unit. You can switch on off the S, which you have it L and I, which kind of replicate the long and instantaneous type of the thermal mag, and that help with selectivity. So you can have different type of protections out of that trip unit with the basic, just standard dials adjustment. Also, with that trip unit, there's an option of having its LSIG, which means ground fault protection as well. If you got a 4-pole breaker, that ground fault can also have a neutral protection. So you can have LSIG and N out of the basic electronic trip unit.
Fantastic. So a lot of granularity out of that basic electronic out of the box. I noticed you spoke about being able to turn off the overload and the short time elements, and that is effectively there's a setting there. You'll see it says ICB, so instantaneous circuit breaker. So if you were, let's say, you had an incoming feed from a generator that had its overload protection already sorted out, as a contractor, you could go through and configure this incoming circuit breaker as an ICB and simplify the selectivity side of it and just have it as an instantaneous only circuit breaker without the need to order special trip units and have more costs and delays and things. It's quite simple for a contractor to set that up.
Yep, that's exactly right, Nick. And you can easily manipulate with these protection settings using the standard breaker without waiting for a special breaker or special trip unit in there.
Yeah, and that I noticed on this trip unit as well, out of the box, you'll see it's got a temperature indicator on there and a pre-trip alarm.
Yep, that's right. So one of the features that we got it for the basic electronic breakers in the P models that you have the pre-trip alarm pre-fitted and it got indication contacts that you can utilize it whenever you want it. If you don't want it, it's still there. It's not costing anything. It's the same cost of the normal breaker. So
Yeah,
you can utilize that one. Plus the temperature indicates about how hot is that breaker. If you went to a limit or the red limit of the breaker, the temperature alarm or the temperature indication lit will start flickering. That means you need to look about what's going on around the breaker and how you can fix it. So
ex-
in that basic electronic trip unit, although it's basic, but it got nearly all the features you wanted. And
yeah,
that's why it's from my favorite trip units.
excellent. Hey, another thing we did talk about this briefly before, the brand new contact design, and we'll see how this helps out our customers a bit later with their designs. So
Mhm.
new contact design, fast tripping. So faster tripping means less let through energy
That's exactly right. So
going
it reduces
forward.
the electrical energy in the type 2 or the motor starting configurations, and it also helps with improving selectivity and cascading with miniatures to have a higher figure, which we're going to talk about later on.
Excellent. And Watts loss as well, up to 40% improvement. It's
That's
fantastic.
Yep. So Truzaki are a big manufacturer of molded case circuit breakers and air circuit breakers. Also, and beside that business, they got Switchboard business. And when we told them about the watt losses as a key factor in the boards for which affect the rating of the breaker, affect the temperature inside the board, they look for it and in their mindset that they need to find a way to help the switchboard builders and the customers optimize their design without affecting their temperature. So one of the key focus points that they got it is how can they reduce the watt losses, and they made it, and they got up to 40% improvement from the TB2 watt losses.
Fantastic. Depth of breakers and dimensions. That's something that I know a lot of switchboard builders have brought up with us in the past. They're always looking for improvements on the size front.
Yep,
So in this case, up to 70 kA, 160 and 250 amp frame, 69 mil deep.
that's right. So one of the feedback, as you mentioned, is that the switchboard builders are frustrated from the different depths of the breaker within the same frame size up to 70 kA as a key one. And also that difference in the depths is due to the difference of trip unit. One of the key ones and the key requirements for Terzaki in their development was to maintain the depths of the breaker as a shallow depth, not as a deeper breaker. So they managed to get 160, 250, up to 70 Ka within only 69 mil depths. And that's regardless what trip unit, regardless what short circuit.
Excellent. And then on the same sort of theme, going between TemBreak 2 and the new TemBreak Pro, I know one of the factors here is around if you've got stuff on a chassis and you're trying to retrofit things. So if you take into account some of the changes with AS3000 recently, um, and what that means from a repair versus alteration perspective, being able to, in these examples you've got here, if you had to replace an old TemBreak 2 product on a chassis, it's quite straightforward to be able to replace it with the TemBreak Pro and not have to modify or change anything in the switchboard.
So you're right, Nick. So in Terzaki mindset, what happened between TemBreak 1 and TemBreak 2 was a big improvement. They tried to reduce sizes in many cases. And between TemBreak 2 and TemBreak Pro, the main key requirements is maintaining the footprint. As much as we can, we don't affect the footprint so that it's backward compatible. So if I got, let's say, a P160 amp breaker, I want to fit it on a 1 to 5 amp chassis, which is the XA chassis, I can still fit it. There's a retrofit kit that has been developed to help to fit it. Also, with the XB chassis, the good thing about the 250 amp frame, all the new breakers now can fit on the XB chassis without any requirements to modify or adjust. And with the 400 630, it's the same footprint, same mounting points. So the customer, whenever they want to change it, they don't have to change the mounting points or the bar works. All the three frame sizes can fit easily in the same spot, saying that even the 800 and above, they got the same footprint, same design. So the customer will not need to change any kind of bars, which makes in the AS3000, you don't have to retest or go for redesigning the whole board to match the new 61439 requirements.
Excellent, excellent. So let's have a look at some of the high tech side of it. So these are the blue label metering style breakers. Now, particularly, we're going to focus on this one here, which is the new smart super compact 160 amp frame size. Now, if I'm correct, George, that's a picture of your hand. You're actually holding this 160 amp frame breaker.
Yep, that's right, Nick. As you know, my hand is not that big, so that breaker is only 90 mil wide. So
Unbelievable.
that's make it very compact, and it got up to 160 amp as a trip unit. Also, the trip unit as electronic ones can have the full ratings up to 70 degrees without derating.
Okay. Well, we'll talk about that a little bit later on, but just looking at these from an energy metering point of view, over 260 monitoring values available. That's huge, isn't it?
Yep. So the monitoring values, we're talking about phase current, we got phase voltage, line voltage, power factor, harmonics. You got massive number of variables and values that you can measure it out of just a small choppy 1 to 160 amp frame.
Yep.
Also, it can go even for a bigger step where it helps the operators to find out what's going on with the breaker, what has been used, what are the event happened with the breaker before, with 126 event logs. and that includes tripping history and adjustment history. So if one of the operators opened the trip unit and readjust it, that will have event log and it will tell the operator when did it do it.
Excellent. Setting securely. Now this is quite a unique feature of these smart breakers with the smart trip unit. I noticed in this case here, you'll see the screen is actually removable. You can not only lock off and put a security tie through the front and secure it, but you could even remove the screen if you didn't want anyone to be able to ever access it.
Yep. So and that's the smartness of that breaker. The display is mainly to display the data inside the trip unit. All the data is stored inside the trip unit itself. And whenever you want to remove the display, you can remove it, and no one will have a clue about how to readjust that trip unit through the screen. That's one. The other good thing about it is it's not just at sites. Even in Switchboard builders, when we launched in the States, the feedback we got it from Switchboard builder that they're happier because now they can configure the breaker, lock on the trip unit, get the wire lock on the trip unit cover itself, then remove the display, give it to the end user, and they can use it without no one touching the settings they've done it. So it's make it more secure for the sites and the end users, as well as the switchboard builders.
Excellent. And configure easily. So this is again another unique, very helpful characteristic of the breaker, where you can soft rotate the display of the screen depending on how you're orientating the breaker in the switchboard.
Yep, that's right. So majority of the times the breaker is mounted horizontally. So if you got a meter and you want to read the data out of it where it's written in a vertical way, it will be hard to read it. So what Trozaki said is, okay, let's make the reading of the trip unit data rotated softly. And that it's just by adjusting it in a setting in one of the settings inside the trip unit, and you can make it as a 90 degrees angle for 360. So you have it in every 90 degrees, you can have an angle for it.
Perfect. Excellent, excellent, excellent. Now let's have a talk about those manuals. A lot of guys at NHP have been working with Terasaki on localizing the manuals and the installation manuals, user manuals, so they're very easy to read, easy to follow. It's not, just filled with pages and pages of data that you don't necessarily need. We've really tried to focus on that. They've all been launched. They've all been created. So you're pretty happy with all the manuals, George?
Yep. So thanks for the technical team that we have it here, and also the feedback we got it from the sales team would helped us to cover what we're looking for. So with these manuals, you got two types of manuals. One is the installation manual and the other one is a user manual. The installation manual currently is based on drawings and pictures of the product, guiding you through how to install the product, how to install the accessories on it, how to install the critical parts on the breaker itself without saying much more than that. So whatever language, whatever way you see it, you don't have to read as much as you want. It's just looking for pictures which help everyone to install it easily.
Good. And
With
when you just looking at this as well, George, though, we've got new verified selectivity tables. So a fair bit of work was done bringing those out.
Yep. So with selectivity, we've done massive number of testing, and we're talking about months of testing to make sure that any figure inside that table has been verified, be backed up by a test at the end to make sure whenever sites take the breakers, take the miniatures and use the selectivity tables, we secure the power and the availability of power as long as we can.
And it's also helped with the type 2 coordination table development, hasn't it?
Yep. So the improved lateral energy helped with the cascading of the miniatures as well as the type 2 coordination tables. So that improved size helped to reduce number of configurations to a lower frame size, plus helped to get a higher KA rating compared to what we had before. So it
And
improved it.
And for the consultants and designers out there, from a software tool, we've got TemCurve and PowerCAD. All the libraries have been updated with the new TemBreak Pro breakers.
That's right. So TemCurve is available. The PowerCAD updates, Adrian from PowerCAD has been working on it, and it should be live by the time we're talking now. But all of them have been reflecting the latest features of the trip units, the latest data of the breakers, so that you can easily select it and securely design it.
Now, if people want to get access to the manuals and the tools, brochures, CAD blocks, all sorts of things, you've been working with the IT team and set up a new landing page.
Yep. So the key thing that the customer would like to have for designing the breaker is from a consultant point or the switchboard builder or contractor as an installation as well, is to get the right documents and the right support for it. So if we looked in the TemBreak Pro website, you can easily get drawings, whether 2D or 3D drawings. You can have the software for the TemCurve version directly on the website, so you can download it and use it. You can use the user manuals to know how to commission and start the breakers. You can use the installation manuals and the technical documents to select the right breaker, as well as to make the right design for the breakers. So all of that is available online directly, 24/7. Whenever you want it, you can look there and get whatever you want.
Fantastic. Fantastic. You've also made a new selection tool for customers to use.
Yep. So we know that the part number is a new part number for the market, so they haven't got it out of their heads. And the easy way to do it is to make their life easier by the selection tool. So all you need is follow the data you have it, fill in the data you have it, like the ratings you have it for that breaker, the short circuit, the KA rating you're looking for, the frame size, if you know it, the type of strip unit, the number of poles. Then by selecting these selections or the ticking the boxes here, it reduces the number of results and the number of selected breakers for you. And once you downsize it to a reasonable number and you select one of the breakers, click on it, it will drive you to the portal where you, if you got the NHP account, you can download the data sheet, you can check the stock availability and the price as well for you.
Fantastic. All the tools that you need are there. All right, we've covered off on a couple of the main points, but as we started this conversation, some of the real strengths of the breaker linked to the new contact design, which we said trips faster, reduces let-through energy, and also we've had the temperature performance optimized. So when you start to put all those things together, it can really drastically improve the performance of the overall switchboard. So let's have a look at the optimized range. All right, so in this example here, George, pretty typical layout. We have a generator, we've got a kiosk with an LV outgoing section, we've got our main switchboard and a couple of panel boards hanging off that, which will be connected to your typical loads, power, lighting, mech services, whatever it may be. So it's pretty standard approach. And when we look here, well, what can you tell us about the setup? Because I can see a whole lot of different things going on in this switchboard.
So as you know, Nick, from the starting of the board, you got the ACBs in here, and the ACB is one of the best in the market where you can have the close transition and fault clearance between the breakers in less than 30 milliseconds, which has been proven in the market many times. So you're starting from that point, going to the bigger frame sizes of the MCCBs, then feeding the final tier where you got the small frame sizes feeding directly the load or the panel boards. And in the key one or the start point that we're talking about, temperature is a key factor for selecting these small breakers. Because from a switchboard builder, from end user, from contractor or consultants, all of them care about the footprint and how can I reduce my footprint, increase the packaging density within that tier to fit more breakers, get more amps, feeding extra loads out of the same footprint. So when Terzaki thought about it, what they did is they redesigned the trip unit and redesigned the contacts to be able to manage a higher temperature And we're talking here about up to 70 degrees with a 250 amp trip unit, regardless what frame size, regardless what trip unit, you can go up to 70 degrees for electronics. And for the thermal mag, it's being calibrated up to 50 degrees.
50 degrees. So just to summarize that up, George, in this outgoing tier, you're saying that the new contact design and the trip unit, if I was dealing with this example here, being a basic electronic, that can operate at full rated current up to 70 degrees ambient temperature.
That's exactly right. Up to
Wow.
250 amp trip units, 70 degrees electronic trip units without any derating.
Yeah, and if you think about it, that's on those outgoing circuits typically where the more you can pack into a tier, the more economical you can be as well. So the more for a switchboard builder, the more cost competitive you can be while still maintaining a high level of performance.
That's right. Also, thinking about it, within that tier, most likely the temperature around the breaker will be sitting between 50, maximum 60 degrees within the same tier. So, which means you can get the full rating most likely out of that breaker.
Yeah, exactly. That's a huge step forward because I know, if we talk about TemBreak 2 or other multi-case breakers that you find on the market, typically when you're getting into those sorts of ambient temperatures, you've got to start to derate the breaker. So in other
Mhm.
words, reduce the number of amps that you're pulling through those breakers. So this is a huge step forward and great for designers and end users and switchboard builders. Fantastic. Okay, let's keep on going and let's move through the switchboard now and have a look at this larger multi case breaker. So in this case, we will be talking about our P630
Yep.
and current limitation.
So, the short circuit network starts from the transformer going through the ACBs, through the main MCCB that feeds the smaller ones or the miniatures directly. And in that case, when Terzaki designed the board, or because they're designing the board, when they look overall the network, they found out if I reduce the electro energy through one breaker, it will be dropped for all the breakers. And in that case, what they thought about is how can we get the lead through energy and the peaks through the network optimized to a level that it's safe and help with improving selectivity, improving durability of the breaker, as well as improving cascading figures and type 2 coordination. And the way they thought about it is the best is let's redesign the contacts to be dual rotary contact and make it in the 400/630 so that it won't affect the size of the breaker. It's the same footprint of what we have now, but with massive improvement in the peaks and the energy going through it as through short circuit level.
Okay, so from that, we've optimized the electro energy side of it and the eye peak. And on the outgoing side, with the smaller breakers, we've optimized the temperature as well. So we've got a very good combination between the two now,
Yep,
improving the overall performance of the switchboard.
that's right.
So then when we're talking about power availability now, which for the end user is the number one factor, what can you tell us about the selectivity between these outgoing circuits and the incoming circuits with our miniatures and RCBOs? Because as you said, a lot of testing's been done on those in the last year or two.
Yep. So we managed to get out of the electronic trap units up to 50 kA selectivity without any issues with the miniatures. So, and even the RCBOs, when we tested it, we were able to get 50K out of it easily. So that's a good thing about it. And the majority of the market is sitting between 36 and 50K projects, which means that we cover majority of the projects with our normal selectivity levels.
Mm. Yeah, and that's absolutely huge. So again, it all comes back to reliability of supply in that regard. So be it a commercial job, an industrial job, we've been able to demonstrate an amazing result between the multi-case breakers and the miniature breakers for selectivity.
That's right. And it's not just that one, Nick. What we did also is the fine adjustment of the trip unit. helps with making the curves easily and fine-tuned to help with improve the selectivity at sites.
Excellent, excellent, excellent. So now the other thing that a lot of people have been talking about, it's very topical at the moment, is ASNZS 61439. So a lot of the switchboard builder partners that we have and customers that we have are going to do testing at the moment. Test station's very, very busy, and they're going through testing out their designs. And I suppose based on what we've been talking about here, a lot of the testing and performance for a switchboard does come down to temperature limitation and short circuit testing, are two major tests that that require the board to perform, mechanically, structurally well, and be able to regulate temperature to get the most out of that switchboard. So I guess when you think about it, looking at what we've just discussed, if you're going through as a switchboard builder and you're looking to put together, test reports and certificates, utilizing the key strengths of the new range, certainly make that a lot easier to achieve. You would think, wouldn't you?
Yep, that's right. So with the new range, it's easier now with the panel boards when they are tested. It's got the electro energy and the temperature elements of that new range, whether it's reduced watt losses, whether it's a higher temperature rating factors. All of that helps to pass the short circuit and the temperaturized testing inside the panel boards as well as the switchboards with the new let-through energies of the rotary contact design and the 400/630 amp frame, it helps to reduce the let-through energy all over the switchboard and get a better figure, better short circuit levels without increasing the bus supports inside it.
Hmm.
So it reduces cost as well. So overall design with the new breakers, it helps to optimize the design, reduce the cost, as well as achieve a higher figure and improve figures with the testing.
Excellent. So if I'm an end user looking at this and I'm dealing with my consultant, I might be doing an upgrade to a plant or putting a new switchboard in, and I'm looking for verification for 61439, then finding a switchboard builder that's done this testing, and if they've used TemBreak Pro, you can be very confident that the overall performance of the board is uh, is certainly going to be first class. And you look for the documentation would be my advice to any end user when they're assessing a switchboard design. But at the same time, as an end user, you should be looking at the testing that's been conducted for your panel boards as well, not just your switchboard. So look for that documentation. There are some suppliers, like NHP is one of them, that obviously we have gone through and done 61439 testing with our panel boards. So we can provide SDocs, their supplier declaration of conformity documents. We've got all that available for customers to go through and consultants to go through and have a look at. So we strongly encourage you, give us a call if that's something that you'd like to know more about. And I suppose summing it up, George, when we look at it across the board with the new range for a switchboard builder, for a consultant, or for an end user, if you're looking for reduced energy let through, if you're looking for temperature limitation and being able to operate at those higher temperatures to get the most from a technical and an economic advantage out of your circuit breaker, high selectivity figures, verified type 2 coordination, then the Terasaki TemBreak Pro certainly has an awful lot to offer in that space.
Yep, that's right, Nick. And with that new optimized range, you're not looking just for improved performance. You're looking for how you make your even the boards and the designs reduce footprint, improved electro energies, help to get a higher short circuit level with the smaller breakers, with a smaller design, without affecting your overall cost. Because at the end of the day, everyone was looking to how can I get the best out of that breaker with a reduced design and optimized design and reduced cost. So all of it, it ticks all the boxes for switchboard builders, consultants, end users, and contractors as well.
Fantastic, fantastic. All right, George. Well, what what we're going to do is, if people have questions or anything that they want to post through, please, we encourage you, post those through. We'll keep monitoring those, and we'll be responding and replying to people that are posting through their questions around TemBreak Pro or anything related to TemBreak Pro, and we'll go from there. So thank you very much for your time, George. I hope this has been a lot of fun for you and people have gotten a lot out of this presentation.
Thanks, Nick, and I appreciate your help because you've been involved in that one, and it's been a long time. We've been working together to get it out, so it's really good to have you back on the webinar. And thanks everyone for your time. We'll be looking for your questions and we'll be answering it and getting back to you in the soonest time possible. Thank you.
Thanks, George.